All right, welcome back. This is video 4 in our materials parsimony series. And now we're going to move on beyond green screening. We saw green screening had the collateral benefit of driving materials parsimony. Once you begin eliminating materials from your palette for purely environmental toxicology reasons, you dramatically reduce your palette. What we want to do now is see how we can embed value in the materials in our products. Because if they're valuable, they'll be recovered for purely economic reasons or commercial reasons, right? So the question is, how do we embed value into our materials? And we start by looking at gold. I think everyone would agree gold is a valuable material. And what makes gold valuable? Well, it's a concentrated monomaterial, and it can be used for a variety of things. It can be used for jewelry, it can be used for dental implants, it can be used in the manufacture of electronics, and a variety of other things. And it can be recovered and reutilized without degrading its properties. So gold is very valuable, and people spend their life trying to recover it or capture it. Right? But what makes materials valuable in a circular economy? And if we ask that question, you have to realize that things become valuable in a specific context. All right? So water, you could argue, is the most valuable thing to a human being, because without water, we die. But, you know, I live here just outside of Washington, D.C., and I could have to argue that water's not valuable. I can just go open the sink and it comes out basically for free, and I can let it run down the drain as much as I want with little or no consequences to my life, all right? So in the context of, you know, Washington, D.C., water's really not valuable. But if I was in the middle of the desert with just one canteen of water, suddenly that water would be very valuable, right? So it depends on the context. And our question is, what makes materials valuable in the context of the circular economy? And if you do that, you have to argue that it's the ease of reutilization, how easy it is to recover and reutilize the materials that makes them value in the context of the circular economy, right? So we can begin to look at why materials parsimony is a powerful first step in giving materials value in the circular economy. You can begin to see why. And I'll give you the example here of Herman Miller. This is a Herman Miller chair. And in the 90s, Herman Miller, like late 90s, early 2000s, Herman Miller began working with MBDC to try to see if they could make more sustainable chairs. And so one of the first things that the consultants had Herman Miller do is take apart your own chair and see how long it takes. So you got these executives, these vice presidents, and here you can see, you know, trying to take apart a chair. And it took them, you know, over 2 hours to disassemble the chair. And when they were done, you had this. And right away, you can begin to see the problems with materials proliferation. Because what they ended up with was, you know, about 24 little piles of a bunch of different materials. Now, if you want to recycle these materials, you got a real problem, because first of all, if you have 24 different materials, you need 24 different recycling processes. And the other thing is, because there are so many different materials, there's only a very small quantity of each. So there's not very much material there, so it doesn't make it very exciting to try to recover that. And this is where we begin to see then the power of materials parsimony in helping to embed value in this, right? So it's the amazing thing is you're really going to see that less really does equal more. Less materials, fewer types of materials does equal more. So if you have a product, let's say this is the full volume of the product, and it's divided up between 12 different materials, well, all these materials are going to have a relatively small amount because you have to divide that up by 12, right? Whatever the volume is divided by 12, you get a small number. But if you apply the materials parsimony rule and dramatically reduce that, let's say down to 4 materials, suddenly the volumes of each of these materials shoot up because you're making bigger chunks of the product out of a single material, right? So fewer really is more. And that actually then goes a long way to begin building value, embedding value into the products, into the materials, so that they're going to be desirable and they're going to be gone after because of their commercial value, right? So you can see here's a separate example. This is another chair manufacturer. They redesigned their chair, and you can see it can be taken apart relatively quickly, and you're left with a far smaller number of materials. There's about 7 materials that went into this chair. And you can see there's fewer piles and bigger volumes, right? So that, assuming that those materials are useful and they can be reutilized in the system, this is then a much more optimized opportunity if you want to try to recover these, right? So we've gone now from a chair made of 2 dozen or 3 dozen different types of material down to a 7 material chair. How low can you go? Can you get it down to 5 materials? Can you get it down to 3 materials? Can you get it down to 1? Well, the interesting thing is there's a design trend around something called monomateriality. That's building products out of one material. So this is a suitcase by Toomey. Samsonite has done something similar, and it's a monomaterial suitcase. It's a suitcase made out of a single material. I had a student who took my class and went to work at his company. They make high-performance bags for camera equipment. He came back within a few weeks that he had designed and they had produced a monomaterial bag, right? So it's actually, the potential for materials parsimony is large, right? We just sort of have not been focusing on it because our innovation is about the new and cool material, not the new and cool application of an existing high-performance, reutilizable, sustainable material, right? So, monomateriality is a trend, and I think there's a lot of opportunity for that going forward. But anytime I show this, I'll have people in the audience I'm speaking to, an industry association or something on these principles, and someone will say, yeah, that works for a suitcase, but what about a car? Cars are much more complicated. And you're right, an automobile has tens of thousands of parts, and each of the components in the car, I think it can break down, and it's made of dozens and dozens of components. It's sort of like those Russian dolls, there's just parts and parts and parts and parts. And so that might be a daunting task, wow, can we think about materials parsimony for an automobile? It is for traditional manufacturers, but there's a company, a new company, Local Motors, that has a different approach to manufacturing, uses 3D manufacturing technologies and other approaches. And they said, okay, can we make a more simplified automobile? And this is actually their advertising. It says your car has over 20,000 parts, ours has 40. They were able to dramatically reduce the number of materials, and obviously you can see immediately then the complexity of the vehicle. And then the more interesting thing on top of that is, even though there are 40 parts, about 80% of the vehicle is captured by 1 or 2 different materials. So dramatic materials parsimony, dramatic concentration of materials into larger and larger volumes of the product, assuming that those materials can be recovered and reutilized. This is a far more attractive, far more valuable, it has embedded value into the product for recovery in the future. And this is where the power of materials parsimony comes from. It comes from carefully selecting a carefully screened portfolio of materials and embedding value in them and ensuring that they are easily recovered and reutilized. And by reducing the number of materials, you dramatically reduce the challenges of doing that. And you embed value into those products, right? So this is a foundation, again, of the materials parsimony rule. We'll look at future rules about how we can take advantage of this. But materials parsimony is a great first step and something that should be considered even if you're not trying to come up with a closed-loop manufacturing system. All right, I'll see you in the next video.